Welcome back. My name is Mr. Monty, and this is going to be lesson 2 in our 2020 series. That's 20 lessons, 20 minutes apiece for 20 days in preparation for the college placement exam at the community colleges here in Spokane. So lesson 2 today is a continuation of lesson 1, which was I can find 4 coordinate points given a function. So let's get started. If we remember from lesson 1, draw yourself a 3-column data table. We're going to pick 4 arbitrary values to use in our function that'll help us find those coordinate points. All right. Our 4 arbitrary values we're going to substitute in for x. Let's get started. Minus 2 in for x. So that's 3 minus 2 times a minus 2. This can be a little bit confusing, but 3 minus 2 times a minus 2. So that'll be 3 plus 4, which will give us 7. So our first coordinate point is minus 2, comma 7. The second arbitrary point, minus 1. Let's plug in a minus 1, 3 minus 2 times a minus 1. 3 minus 2 times a minus 1. So that's 3 plus 2 gives us 5. So our second point will be minus 1, comma 5. The third arbitrary value for x, plugging it in, be 3 minus 2 times 0. Minus 2 times 0 is 0, so we're going to have 3. So our third point will be 0, comma 3. And our fourth arbitrary value will be 2. Let's plug that in. 3 minus 2 times 2. 3 minus 2 times 2 would be 3 minus a 4. Give us a minus 1. So our fourth point will be 2, comma, minus 1. So we've actually done the calculations and found our 4 coordinate points given this function. But let's take this and actually plot those points on a grid and see what we come up with. Start with our first one, minus 2, 7. Our second one, minus 1, 5. Third one, 0, 3. And our fourth one will be at positive 2, minus 1. Let's see what kind of a shape we've created here. And because it's a function, that means it goes on forever. There were no limitations put on this, so we'll make sure we put arrows on the end of each one, meaning it goes on forever in both directions. Let's answer a few questions about these 4 coordinate points and what we've created here. Family of functions. Well, since we used a ruler, we can see that it's linear. It's a straight line. So let's answer this first one. We're going to say linear. So it's a linear function. Slope. The slope. If we think back to the slope-intercept form of a function, ax plus b. We can actually answer this by reading it. The a value, and in this case, you have to make sure that we keep that sign minus 2. Our slope, minus 2. I want to spend a minute and talk about slope and what that means, because in the lessons that coming up, we're going to see slope, rate of change, the change in y divided by the change in x. We're going to see a lot of that. So let's spend a moment here and talk about it. Slope. The slope of this line, well, we can actually write that as the rate of change, or we can write it as the change in y over the change in x. Well, what does that mean? The change in y's over the change in x. And in this case was our -2. We already had that, but we could actually calculate it giving these points if we needed to. Y-intercept. Let's make sure that when we actually sketch a curve, draw a graph, plot some points, we always label our y-intercept. So I'm going to label that at that 0, 3. As the y-intercept. The last thing I want to answer and talk about is domain and range. Again, we're going to see domain and range quite a few times in our 20 lessons because a lot of colleges really emphasize that knowledge. Domain. Domain means the x values that allow this function to happen. What x's can we put in there? So in this case, we can see that it goes on forever in a positive direction, on forever in a negative direction. We want to know what x values can we put in there. Well, in this case, all. It goes on forever, so really big x's work, really negative x's work. So we can actually say all real numbers, abbreviate ARN. In math terms, we can actually say minus infinity less than or equal to x less than or equal to positive infinity. The y values, the range. What values come out of here? The output, thinking of a function, we have the input, which is the x's, now we have the output, the y's. What y's come out of here? Well, again, we look back at our graph, and we said it could go on forever in the positive y direction, goes forever in the negative y direction. Okay, let's write that. Again, we're going to say all real numbers, or in this case, minus infinity less than or equal to y less than or equal to positive infinity. Make sure you refer back to your teacher and ask them what form they would like that so that you can get full credit on any of your assessments or homework that you do. Our original objective today was to find 4 coordinate points, and we did that given a function. So we've accomplished our task for today, and we went a little bit further and answered some questions about the final sketch that we drew. So that wraps up today's lesson. So we'll see you tomorrow for lesson 3.